Hello friends, this is lesson 23rd. So here still we are talking about machine learning essentials. So in this lesson we are going to cover these topics: training and testing model, then we'll talk about cross validation, and we'll be providing you some examples for them. Let's start with the first topic here. So the first topic is testing, training and testing the model. So testing or training and testing the model, there are different ways for training and testing the model. For example, the first thing, training and testing the model with the same data. It means we are not splitting the data, just we are taking the same data, applying to the model, we train the model with the same data, and then we are applying the same data for testing it. So what happens here if this is the case? So if the model is trained and tested with the same data, what happens here? Increases training accuracy but overfits the model. That is why, because the model has already memorized all the data points in training phase. In first phase, whenever we are training the model, what happens here? Because we are giving the same data, so the model has already memorized the relationship between the data, the patterns, everything is memorized by the model. So the model overfits. So overfits mean with the model has low bias but high variance, as we discussed in previous lecture, if you remember. So but testing or validating, whenever we are testing our model, the second phase, what happens here then? The model with unseen data, when we are applying unseen data to the model, so testing accuracy or performance is so much low. What happens? Because we have trained the model and tested the model with the same data. So if you are applying the same data again for the model, then the accuracy is so much high, because the model has already memorized everything. So if you are applying the same data and testing with the same data, so the accuracy is so much high. But in the second phase, if you are applying unseen data, what happens then? Because the model has not seen the data and the model has already memorized while we were training the data, what happens here? In this case, the accuracy or performance of the model will be so much low. Now the second case, what happens? In the second case, we will be splitting the data into two types or two sets, we can say, training and testing set. So if this is the case, the model is trained and tested with different splits or partitions. We have two partitions now. One partition is for training and another one is for testing. So testing data is something which the model has not seen yet, but the training is the data which the model is trained with. So this is the data the model have or the model has already seen, but this one is unseen data for the model. So model generalizes better then. If this is the case, then the model will be better compared to the first type. The model generalizes better than the first type, increases testing accuracy but with high variance. Variance is there, still we have high variance, because whenever we are applying unseen data to the model will be good, it can generalize the data, but still we will be having high variance. So here in this split to train and test, so we will be giving some percentage. For example, 80% to training and 20% will be giving to testing. If in the partition, if for example, if you are giving for this one, maybe if by default it is 25 for training and 25 for testing, but we can change the size, like maybe 60 for training and 40 for testing, or maybe 80 for training and only 20% for testing, that we can do. But still we will be having a high variance model, but this model is better compared to the first one, because the model generalizes better, and also we have different partitions. Unseen data is also there in testing phase. Now Here we have some other thing, we call it as a cross validation, or it is also called as k-fold cross validation. So what is this? In this case, this is the process of evaluating the performance of model by splitting the data into k numbers. So we don't have two partitions like as we discussed here. We have only two partitions. We have k number of partitions we have. So the k number of partitions, we have data for training and we have data for testing. K number of partition. Now let's see here. It is used to overcome the problem of overfitting, because in the first case, in the second case we have overfitting. Now we will be using cross validation, and cross validation, by using the cross validation, the overfitting problem will be solved. Not 100%, but still it will be better than the first type and second type. Splitting up data set iteratively and retraining the models and averaging the metrics to get the best predictor of an error. Let me give you an example here, friends. You consider that k is equal to 5. K is equal to 5 means what? We are creating how many partitions? 5 partitions. So we have 5 partitions, and the first iteration or first phase we have, from among the 5 partitions, the first partition goes for testing, and the remaining k minus 1, and it means 4 partitions we have for training. In the second iteration, what happens? This will be for testing. The first partition with the remaining 3 partitions, they will be for training. In the third iteration, this will be our testing data or partition. The first 2 and the last 2, they will go for training. So here you are observing that we are training the model and testing the model with all the data. It means we have trained the model with the same data. We splitted the data into different partitions, and the same model is trained with all the partitions, and the model is also tested with all the partitions. So what happens here? The problem of overfitted is removed. Now we will take a finite number of equal slices of our data. Usually we will be creating 3-fold or 5-fold, or maybe the default one, maybe like we are using 10-fold. So here I use for your example, for your understanding purpose, only k is equal to 5. So we have 5 partitions. Now if the first partition is for testing, the remaining is for training. If the last partition is for testing, so the remaining will be for training. So this testing is iteratively changing and with training data. Now let's have an example for them here, then you will better understand. So we talked about training and testing models. We said we have the first case is like testing the model and training the model with the same data. If this is the case, the model will overfits because it memorizes everything. So whenever we are applying answering data, so the model performance will be so much low. But in training, here the performance may be so much high, because already the model has memorized everything. If you are applying the same data for training, if you are applying the same data for testing, here we have high performance. But whenever we are applying answering data, then there the model cannot generalize, because the model has already memorized everything. But in the second case, the data is split into 2 partitions. We have training and we have testing partitions. Here increases testing accuracy, but we will be having high variance. The model is good, it can generalize, but still we will having high variance. Now let's have the example for them. So you are familiar with IRIS dataset. I am reading the IRIS dataset here. So we have these are the features, and this is nothing but the response value. Now the response value you are seeing, they are in the form of qualitative data. I have to use dummy variables and I am changing them to 0, 1 and 2. So now they are changed into, now if I use here like iris.head, you see they are all they have to be changed. So what is the error? Sorry, because I use it here in the same cell. Let me create another cell, then it will be better. So here I am using like iris.head, but let me read the data. Okay, now the map data, and now see here they are changed to quantitative values. Now let's see here, friends. First type what we had, train and testing the model. So first I will be using on the same data how it happens. So these are my features, 4 features in the form of data frame, and this is the response value. It is in the form of NumPy array, and I'm using KNN, K neighbor classifier, and the neighbor number of neighbors is equal to 5, and I'm giving the same data while here I'm training the model, the same data, and in the testing also I'm applying the same data. Now let's run this and see the performance of our model here. Yeah, here see the accuracy is how much, 97%, and when we are going for testing 100%, because the model has already memorized everything. If you are applying the same data for the testing, so what happens? So the model has already memorized the pattern, everything, so 100%. But if you are applying unseen data something, so this accuracy will be reduced so much, because the data cannot generalize. The data has the model cannot generalize. The model already have memorized everything. Now second type, here we are splitting the data into 2 partitions. Here what is going to happen, the same data I am reading and I am splitting it to training sets and testing sets by using the functions. The function, if you remember, this is the function. So the data is split it into 2 groups or partitions. We have data for testing and data for training. So here I am training the model with the training data. How much? 80% of that will be for training, only 20% of that will be for testing. Here you can change it like 25, if I put 25, so 25 for testing and 75 goes for training. Now let it be 20% for testing and 80% for training. Now we have 2 partitions and I am training the model with some unseen data, and now let's see the accuracy of the model. So the accuracy is changed to 100%, but here we said the testing, if the testing data is applied, say as we said here, the model has some high variance. Here the model has some high variance with unseen data, so the accuracy somehow it is reduced to 83%, but this model is better compared to the first one because it can generalize, because here we applied unseen data and still we have high accuracy. If you are applying any other data sets, still we will be having some high accuracy. The model is better compared to the first one. Now let's see the third type of training the model, and that is using k-fold cross validation. So we talked about k-fold cross validation, and we said it is the process of evaluating the performance of model by splitting the data into k number of training and testing partitions. Let me explain it here for you. This is from my paper, friends. Those who are interested, they can download the paper and read, and that paper also. Here, see friends, I have created how many partitions are there? K is equal to 10. We have 10 partitions. So in partition 1, we have if k is equal to 1 in first phase, so we have how many partitions? 10 partitions are there, but the first partition goes for testing, the remaining k minus 1, which is equal to 9, so that goes for training. So in the second phase, what happens? here we had testing. Now the testing is shift to the next partition. This goes for training and these are the training. So the same, see, the model is trained and tested with the whole data set. Now here the variance is also reduced and the model is compared to the first and second so much generalized. Now here I split the data here. We have, these are the features and this is my output array, and I am using the same k neighbor classifier with 5 neighbors, and here this just by calling the function friends I will be, and here the number of k is equal to 5. You can change this to any number of like here it is 10, you can change it to 10 or maybe 3, 5 like that. Okay friends, see here the model accuracy is increased to how much? 97%, but this model is compared to first and second it is better. Now let's find this sweet spot that optimizes our model complexity. Now the question is, what should be the value of k, and then we will be having an optimal, or we will be having a good model for that. Now for that we said the k value should be an odd number, if you remember, otherwise you have to refer that lecture what I talked about k and n. There I have talked in details. Now I am not going to talk about that. So here I am creating a range of values. It is starting from 1, then incrementing by how much? 2. So the second number will be 3, 5, like that it is going. So odd numbers will be given for us. Here I am applying here the k value. It may be first time 1, 3, like that it is going up to 29 here. And now I am applying cross validation. I am going to compute the accuracy of the model, and then I will be checking the error, and errors are all stored in this array. I have created an array here, a list, so all values are stored in that list. Let me execute this. Yeah, these are the values. You can see here for different k value we will be having the performance of the model is shown here, for 1, for 3, here for 5, for different values. Now we have to check which one is the optimal value for us. For that, what happens here? I will be plotting k range with error values. Now by that, this is the plot. If you remember, we talked about there is a close relationship between bias and the variance. Now whenever bias is high, so we will be having low variance. If you see here this part, we have highest variance but we are having low bias. So what we have to keep a balance in between. What is we should compare the two values and find some values, optimal values, that is in between the two, not that much high and not that much low. Here the bias is high, it is reducing up to here. So this is the minimum bias here for us, and now again it is increased, here again it is reduced. Then from here onwards, so what happens here? The variance of the model is increasing. This one is here from, you can easily say that from 6 to 10, these are nothing but the optimal values for k. If you remember the last lecture, then you can easily understand, because there I explained the graph how these two values are related to they have relation with each other. So whenever the variance the bias is decreasing, what happens? The variance is increasing. If the variance is decreasing, what happens? The bias is increasing. So we have to keep a balance between them. So for that, if I want to find the value of k, the optimal values, say these are the optimal values. We have to put the value of k from 6, like 6, 7, 8, 9, 10. These values if we apply, so we will be having an optimal value for k. So compare this graph to the previous graph. If you remember complexity of the model when we were talking about the bias and variance, so toward the left our graph has higher bias. I explained here higher bias, so it is reducing, it coming to the minimum up to 0. So again what happens here, the value of variance is increasing, so we have to keep a balance between them. So the optimal values for k is equal to how much? From 6 to 10. They are nothing but optimal values. I hope you understood about cross validation, friends, how to train the model with the same data, how to train the model with different permutations like training and testing, and how to apply cross validations. These things were in this lecture. I hope you understood. We covered all these things. So thank you.